So review for the test number 4 for you. Um, Vertical lighting calculation, guys. You have the stuff with you, right? The information. I thought I did have one here. So this is what I gave you guys. Come on, yeah, there you go. So we have using using the point calculation method, and you will be given these two figures. Can you guys see that? I will give you a fig like this, exactly like this fig. You'll have this fig. So fig 1 and fig 2. The foot candle on the vertical surface for each point, and the average foot candle for the vertical surface. That's what this problem is. The foot candle on the vertical as well as the average. All right, so here's the surface that you... Okay, Chad, why aren't you responding? Okay. All right, so let's go directly into this one and undo them. Okay, so here's the 3 points that you guys will get: point 1, point 2, point 3. These numbers, Adam, are the distance in feet. 10, 20, 30 are distance in feet. These numbers here are the angle that they make with the vertical, the angles. And we need to find the foot candle. The formula for it: you take the candela power, multiply it by sine the angle that's made here, sine the angle, divided by the distance squared. That's how you find this formula. Cool? So let's go ahead and calculate that one. Let's do it for the first point number 1, guys. Can you guys see point number 1 right here? The candela power, you need to go to this sheet. Can you guys see that sheet? We'll give you the candela power. I will give it to you. This is fig, oh boy. The fig that's written on you, I can't remember what the fig number is. Here. That fig that you need to go from one of the chapters. Thank you. There you go. 11.2 and 11.3. 11.2 and 11.3, gentlemen. When you go there, okay, there you go. Good. So let's go get the answer. So you're going to go for the first point is at 65, and I believe there is a 60.
What does the FC equal?
Equal candela power multiplied by sine divided by the distance squared. Candela power multiplied by sine divided by distance squared. Apology for my nice, beautiful handwriting. Okay. At point 1, that's the formula. At point 1, guys, at angle 65, the candela power from fig 11.2, the candela power is 335 times sine, the angle, sine 65, divide by the distance is 10 squared. And gentlemen, if you did that, you should end up with 3.03. Done. Where is that point number 1? Point number 1. Point number 2 is no difference. At point number 2, guys, the angle is 55. So go to the sheet at 55, 696. So that will give you 696. 696. Multiply this one at angle 65, sine 55, divided by the distance at 55 is 20. 20 squared. Gentlemen, if you do that calculation, that will get you 1.43 foot candle. 1.43 foot candle. Point 3. Point number 3. At point number 3, guys, the foot candle equal. At point number 3 is 45. Do I have a 45? I made it easier. Yeah, 45. I do have a 45. At 45, guys, is 842. We have 842 multiplied by sine 45. Divide everything by, what was the angle, the distance at 30 times 30. 30 times 30. Divided by 30 times 30. And gentlemen, if you do your math on this baby, it should give you 0.66. 0.66. 0.66. Make sense? 0.3, 0.66. Okay, so that's the 0.1, 0.2, 0.3, guys. Now, we need to find the average. Did they ask about the maximum? Did they ask max minimum? Okay. If I ask you guys about max minimum, here's your minimum, here's your max, right? The average, how do you find the average? The average foot candle equal, you add them up, 3.03 plus 1.43 plus 0.66 divided by 3. And when you do the math on that one, you end up with 1.71 average. This is a max. This is a min. Right? And this is your average. That's it. Now, how easy that is. You think my grandma can do that? So it's really easy. Have the formula with you guys. I'm not worried too much about memorizing formulas. Almost in all my engineering classes I've done. Here's the formulas. Go do it. You know, if you can. Typically, the harder the math gets, got, the more the formulas doesn't mean a whole lot to you. Applying it just means when you have multi-differential equations, boy. Okay, any comments? Can you have thumbs up, Chad? We got that one. So shouldn't so you'll get that one. The second question, my friends, is you guys got it right in front of you. It says Adam was picked to design a lighting system for our room. The room is 40. You guys have this information, right? You have it in front of you. 40 by 40. Adam decided to use a troffer with a 300 lumens, 3,000 lumen, 3 lamps. The foot candle that we want to maintain is 80-foot candle. Light loss factor is 0.8. Coefficient of realization is 71%. And we need to know how many fixtures do we need in this 40 by 40 area. So we have an area here that's 40 by 40. Is my 40 by 40. 40 by 40 area, we need to have fixtures in. Okay, the formula to do this, gentlemen, is the number of fixture equal foot candle times area divided by lumens, lamps, coefficient of realization, light loss factor. Bring that formula with you. Cool. Now the rest is history, gentlemen. Just plug them in. The foot candle is given as 80. The area is 40 times 40. That's my area. Divide everything by the lumens that Adam decided to use is 3,000. He decided to use 3 lampers, more efficient. And the coefficient of realization for that fixture in these spaces is given as 0.71. And the light loss factor is given as 0.8. And gentlemen, if I did my math right, would that end up with 25 fixtures? I think 25. So maybe 24 something and you approximate to 25. Cool? 25. Now, I want you to do the layout. Did you guys hear me? I want you to do the layout of these fixtures, not just the number, the layout. Did it say you have the layout too? Yep, sketch. Here you go. So I thought I did. Okay, now that's how many of them you need. You need to sketch them now. Cool? Let me know if I can go to the sketch. Good, good. You need more time there? Good. Okay, so that's a piece of cake. Where am I here? If you go, guys, to the sketch. Okay, now I have 25 fixtures. Look what I'm gonna do. I have how am I gonna do that? I'm gonna do it right. 25 fixtures. 25. You guys remember how we factor the 25? And find me the two largest numbers that you can multiply by each other to give you 25. Duh, Chad. That's the easiest one that, since I was in the third grade probably, right? That'll be 5 by 5. 5 by 5. What are other combination that you can get? How about 25 by 1? 25 row, 1 column. Now we lost that. Would you do 25 rows and 1 column of fixtures? That's another combination. What else 25? You can get 25. 5 by 5, that's it. 5 is the prime number. So these are your only combination. Or you, so that obviously this, you can use the closest to each other. So that'll give you 5 rows, 4 columns. So here's how we divide them, my friends. When you do that, let me use a different color. So here's my my 5 rows. Can you see that my rows are here? My rows are here, and my rows are here. I'm sorry, my columns, Chad. And this is my rows, and my rows, and my rows, and my rows. Okay? So 5 columns, 1, 2, 3, 4, 5. 5 rows, 1, 2, 3, 4, 5. Okay. Then how do you calculate them, guys? Let's take the x, both it's square. So to find the x, if you guys remember finding the x dimension, so how many rows do I have? How many, to find the x, you need how many columns? How many columns do I have? I have 5 columns, so 5x, 5 2x, right? Isn't that what we have? We have 1, 2, 3, 4, 5. So I have 5 multiplied by 2x equal 40. Okay, and then you take this. Everybody knows why 5 2x. I have 2x. Well, 40 is a dimension. This is 40. 40 feet, yeah. 40 feet the dimension. So you guys can find x or 2x's between them, or like I use here half a y. It's really two. They're the same, either x and half an x or 2x's between them. If you use 5x, 5 2x's, then I should probably coordinate this one slightly different. I want to use this just to be consistent with what we have done in the past, guys. There's so many ways. There's 2 ways of doing it. So this is x, this is 2x, this is 2x, 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 and this would be, the last one would be an x. Oops. So that's how you came up with this. Okay, here's my x, just to stay consistent. Okay, so 1, 2, 3, 4, and these two together make a 5. 5 equal this. So that will give me, guys, when you solve this one, that will give me 10x. 10x equal 40, and x equal what? X equal 4. X equal 4 feet, right? My x is equal 4 feet. Let's go to the y. To find the y, the same thing, guys. Here's my y. 5 times 2y equal 40. Same calculation. 10y equal 40. And y equal 4 feet. Y equal 4 feet. Let's do the y's over here too. So from here to here, guys, to the center. I don't know if you understand. These are to the center. This is a y. This is 2y, 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 and from here is a y. Okay. So then the last thing I need to do is find the distance. This distance from here to the center of that fixture, guys. That's an x. So that x would be, what did we say x is 4? And the distance between the two fixture, which is 2x, and that'll give me an 8. Same thing in the y direction. The y here, guys, is 4. And the distance between them is 8. So can you guys see? So between every two fixtures is 8, and between the fixture and the wall is 4. Any comments, any questions? Everybody knows how to do that? Piece of cake? So tomorrow, guys, approximate up, and if you end up with a number that hard to find, what do you, the 23, for example. If you end up with the 23 fixtures, you can't do a 23 fixture. So make it 24, right? Make it 24, 6 by 4. Can I have thumbs up, Chad? Fully understand that? Good. Okay, that's it. So let's get rid of